Here we're going to take a look at kites and trapezoids. And we're going to start that by just simply defining what a kite is. A kite is a quadrilateral with two distinct pairs of congruent consecutive sides. So AB is congruent to BC and CD is congruent to DA. But AD is not congruent to AB. So there's a top pair of congruents and a bottom pair, or side by side if it was built lying on its side. If a quadrilateral is a kite, then the diagonals will meet at a perpendicular. One of these things useful for on a coordinate plane. Also, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So this is congruent to this, but this angle here is not congruent to this angle over here. If a quadrilateral is a kite, then one of the diagonals bisects the other. So this right here would be bisected by the other diagonal of that kite. If the quadrilateral is a kite, then this diagonal bisects the angle that it is going through. So we get a few of these properties needed to know that this is a kite. A trapezoid, on the other hand, is a quadrilateral that two of its sides are parallel to each other. These two sides are called the base. The other sides are called legs. Now these legs do not have to be congruent to each other. They might be congruent to each other. If they are, if this leg is congruent to this leg, then it is called an isosceles trapezoid. So we have a few things we can know about trapezoids. If a quadrilateral is an isosceles trapezoid, so if this side is congruent to this side, then the pair of base angles are congruent to each other. If the trapezoid has one pair of congruent base angles, so if these base angles are congruent, then the trapezoid is a isosceles triangle, or isosceles trapezoid. So this is working in both directions. If the trapezoid is isosceles, or it's isosceles if and only if the diagonals are congruent to each other. So when given that trapezoid, if and only if these diagonals are congruent, then it is an isosceles. So these are some helpful things to be able to get some of the proofs sort of started, or to start doing some of the proofs. One of the other things that we get about a trapezoid, though, is about its mid-segment. So if I was to just build a trapezoid, one of the other things that we get about a trapezoid is when we know that the bases are congruent to each other. If I was to find the midpoint of each of the legs and build that mid-segment, then I know that this mid-segment is is parallel to both bases. I also know that if I label this, I know that the length of XY can be found by half of the bases combined. So half of AB plus BC. So the length of that mid-segment can be found. I find the midpoint, the half, and that means that that line itself is half of the trapezoid. Remember, math rocks with a capital M.